this is Ben Schwanier, and today we'll be doing percent composition. Percent composition is the percentage by which the mass of each element is present in a compound. Now, all the percents in percent composition must add up to 100%, and there are three types of percent composition. The first one is percent composition from mass data, and the equation for this is percentage of mass by element equals mass of element divided by mass of compound times 100%. The second type is percent composition from chemical formula, and the equation for this is percent by mass of element equals mass of element in 1 mole of each compound divided by the molar mass of compound times 100%. And the final type is percent composition as a conversion factor, and the equation for this is mass of compound times a conversion factor, which is based on the percent composition of the element in each compound. And now we have Alex with some practice percent composition problems.
My name is Alex Tomagalski, and I'll be demonstrating how to do percent composition problems.
The first problem states when a 13.60 gram sample of a compound containing only magnesium and oxygen is decomposed, 5.40 grams of oxygen is obtained. What is the percent composition of this compound? The first step of this problem is to find out what you know, which is the mass of the compound, 13.60 grams, the mass of oxygen, 5.40 grams, and the mass of magnesium, which is 13.60 grams, minus 5.40 grams, which equals 8.20 grams. The next step is to calculate for the unknowns. The unknowns in this problem are the percent by mass of magnesium and of oxygen. To find the percent by mass of a chemical, you must take the mass of the chemical divided by the mass of the compound it is in and multiply it by 100%. After the percent by masses are found, you must add up the percents. The percent should add up to around 100%. The second problem states that propane C3H8, the fuel commonly used in gas grills, is one of the compounds obtained from petroleum. Calculate the percent composition of propane. The first step, like the previous problem, is to find the knowns and unknowns. The knowns are the mass of C in 1 mole of C3H8, which is equal to 36 grams, the mass of H in 1 mole of C3H8, which is 8 grams, and the molar mass of C3H8, which equals 44 grams per mole. The next step is to find the percent by mass of C and H. To find the percent by mass, you have to take the mass of the chemical in 1 mole of the compound and divide that by the molar mass of the compound and multiply that by 100%. The percent by mass of C is equal to 36 over 44 times 100, which equals 81.8%. To find the percent by mass of H, you have to take 8 over 44 times 100%, which equals 18%. Lastly, you have to add up the percent by masses, which should come close to 100%.
Hello class, my name is John Mwangi, and today I'm going to explain the molecular formula and how it compares to the empirical formula. The molecular formula is used to display which atoms are in a molecule and how many of them there are. It is usually a whole number ratio of the empirical formula, such as ethene C2H2, which is 2 times the empirical formula CH. Both the empirical and molecular formula can be the same in molecules such as methanol, which is CH2O.
Hey there class, I'm going to be showing you how to find the chemical formula if you have the empirical formula and the molar mass. First you have to figure out the molar mass of the empirical formula given. In this case, it's 30.03. From there, you have to divide the molar mass of the unknown substance and the empiricals. In this case, you'd get 6. All you have to do after that is multiply the empirical by the number that you just got.
Martin Murphy, and I'm going to teach you how to do empirical formula if you're a little confused.
With empirical formulas, you are looking for the simplest form of a ratio. In this way, if a formula was N2O8, then the simplest form would be NO4. However, in this problem, we are looking for an empirical formula for a formula that has 25.9% nitrogen, and 74.1% oxygen. The easiest way to do this is with dimensional analysis. We assume that there is 100 grams of the substance. In that case, there would be 25.9 grams of nitrogen and 74.1 grams of oxygen. We multiply that by 1 mole of each substance over its molar mass, which is 14.01 for nitrogen and 16 for oxygen. So you divide 25.9 by 14.01 and get 1.85 moles of nitrogen, and then divide 74.1 grams of oxygen by 16 to get 4.63 moles of oxygen. In each equation, the grams of nitrogen and oxygen cancel out with each other. In this type of equation, you take the smaller number of moles and divide it by each set of moles. So you divide 1.85 moles of nitrogen by 1.85 and get 1. Then you divide 4.63 moles of oxygen by 1.85 and get 2.50 moles of oxygen. So does that mean that the empirical formula ratio is N1 and O 2.5? No. If you remember Mr. D's chart that he put on the board, when there is something 0.5, you multiply both sides by 2 to get N2O5.
Matt Ellis here, wrapping up what you just heard about in this wiki. First, you heard from your good friend Ben Schwarnier, who taught you all about percent composition. Ben partnered with Alex, who taught you how to solve these percent composition problems. Next, you heard from John Mwangi, who taught you about the molecular formula, gave you some background, and compared molecular formula to the empirical formula. Next, you heard from Matt Foster, who taught you about solving the molecular formula. Finally, you saw your good friend Martin Murphy teach you all about the empirical formula. Well, guys, I hope you learned a little something here today that you may have been confused on. And I hope that this video is able to help you out with your tests coming next week. I want you all to have a marvelous day, and good luck in your tests. Thank you.